and welcome to STEM Stories with Mr. Ewing. We have a really interesting book for us to read called Earthquake by Ellen J. Prager. Now, one thing before we read our story today, I want to point out that there's a little crow in our book. I'm really interested in find out what the crow has to do with earthquakes, and I wonder if we're going to find that information out in the book. Let's jump in and read and find out. Earthquakes by Ellen J. Prager, illustrations by Susan Greenstein. To all those who have dedicated their lives to earthquake research, education, and preparation, and rescue in the aftermath of disaster. For my wonderful family, Phil, my husband, and Gina, my daughter, who have helped me to see what is special about each day. I read these dedications because I think they're really important to the story and why these two people were passionate about writing this book about earthquakes. All right, let's read along. Now, it's really interesting too. Our stories, the written part, tells us a lot of information, but the really great thing about a picture book is the illustrations are also going to provide a lot of information for us. So some of the pages that we are going to look at don't have words. They have really important pieces of information like that. Shake, rattle, and roll. Buildings, trees, and the ground sway when the earth gives way. Earthquake! You see the earth is starting to crack open. And there's our crow. Wonder what that crow's telling us. Any ideas? Do you have an idea what the crow's telling us? Let's find out. Earthquakes happen on Earth every day. Most are small, too small to feel. But at least once a week, there is a strong earthquake somewhere on the planet. A strong earthquake can mean disaster for people who live nearby. The ground shakes, jumps, and rolls while people run for safety. Buildings may crack or crumble. Roads can be ripped apart. What causes an earthquake? Take a minute to talk to a sibling, a friend, an adult. What do you think causes an earthquake? It's a lot going on. If you were there, how would you be feeling right now as an earthquake rumbled around you? I think I'd be pretty scared. Maybe you're excited. Ooh. They're showing Earth splitting open underwater. Did you know earthquakes can happen underwater too? Earthquakes begin when rocks inside the land or under the sea break apart. Rocks can break when they are squeezed, stretched, or pulled in different directions. Ooh, look at the faces on the marine life, the fish and the seahorses. I think I'd be a little worried too. And this is showing us with this arrow how the earth can actually split and open up, dividing pieces of land. It doesn't matter where it is or who it is. Rocks break sort of like a rubber band that has been stretched too far. If the rocks are stretched, squeezed, or pulled too much, they split apart, then snap back slightly out of place. When rocks break, lots of energy is released. Where do you think that energy goes? It's a good question. Breaking rocks send energy into the ground. The energy causes the ground to move in what we call an earthquake. To a person, an earthquake can feel like shaking, a sudden jolt, or a slow roll. An earthquake can last for just a few short seconds or go on for several long minutes. Wow. I love this picture. If you look at the yellow burst down at the bottom of the page, it's showing us where the earthquake actually is centered, sending those waves out to when they actually come to the ground level. A lot of earthquakes, even though we see the effects at the earth level, they're actually starting way below ground. It's a really good illustration. Most earthquakes happen because Earth's outer surface is moving. Like a huge jigsaw puzzle, the planet's outer surface is made up of big pieces called plates. These plates move very slowly in different directions. So slowly you can't feel them moving. Over time, the plates slide, slip, and bump into each other along their edges. I wonder if it's like a plate that we eat out of, or is it a different type of plate? This might be a really good time to jump on a computer or a phone and look up Earth's plate and see if you can find some more information about that. But if we notice here in our picture, again, remember, those pictures can tell us a whole lot. It talks about all the different plates: the North American plate, the Caribbean plate, the South American plate. Every part of the world, our planet, is broken into different types of plates. Most earthquakes happen along the edge of the Earth's big plates. Let's look at the map on the next page showing earthquake activity. Can you name 2 places on Earth where earthquakes happen a lot? And I'll give you a hint. If you look at our little box in the lower right hand corner, it will tell us what to look for where earthquakes are happening. But if you look at the far right hand side of the picture, there's that little red dotted trail. That's where a large majority of earthquakes actually happen. We're going to look at one place in the United States called the San Andreas Fault. Earthquakes are common in California, especially along the famous San Andreas Fault. 2 of the Earth's big plates meet at the San Andreas Fault. These 2 plates move in different directions. Over time, the rocky edges of the 2 plates bump and stick together, slowly stretching and pulling. Every once in a while, the rocky edges break, releasing energy and causing an earthquake. In an earthquake, the ground may move up, down, or sideways. Sideways motion is very dangerous because it can cause tall buildings to sway back and forth or weak houses to collapse. In areas where earthquakes are common, people are learning how to build homes and buildings that stay safe when the ground moves. If you think about all the buildings that we go into and live in, what if there was an earthquake under them? How would we make them stronger? In places where the ground is made of soft sand, shaking can cause buildings to sink down and tumble over. Where earthquakes happen, buildings and homes should be specifically designed and built on solid ground. This is a really great illustration that shows the engineering or how buildings are built. These inside pictures are showing that these big metal plates are actually erected with the building over it to keep it from toppling over. Believe it or not, most buildings and homes, and especially in earthquake areas, are actually designed to sway or move just a little bit. That actually keeps them from breaking apart if they're built too sturdy or inflexible. Sometimes there are many small earthquakes before the big one. These are called foreshocks. Now, shock, if you think about it, is a rattle, and for, the prefix on that word, means before. These are before shakes or rattle before the big earthquake. After the big earthquake, the main shock, again, there are maybe many small quakes. There are what we call aftershocks. So there's 3 different stages of the earthquake. There are the foreshocks, there is the main shock, the main earthquake, and then the aftershock. And the aftershock can be a little unsettling. After an earthquake, you'll have these little trembles and you'll think it's another earthquake, but they're just the residual shock or energy left over from the main shock of the earthquake. There's a really great illustration. One of the things that we don't tend to practice so much here in New York City, because we're not on any major fault lines, it's not very common that we would have earthquakes, but it's always good to know the practice and safety of what to do in case of an earthquake. Safety of an earthquake. Stay calm during an earthquake. If outside, find an open place away from power lines, buildings, or fences. If inside, stay away from the windows. Take cover under a sturdy desk, table, or door frame. Number 4, listen for instructions from a teacher or parent, or listen to the radio for information. No one has found a sure way to predict earthquakes, so the best protection is to be prepared and know what to do. Find a safe place and stay away from things that could come crashing down. Extremely good advice. We cannot prevent earthquakes from happening. Earthquakes are part of Earth's changing nature. Scientists study earthquakes to learn more about them and to help prevent injury and damage. One day, we may be able to predict earthquakes and give people some warning. Have you ever felt an earthquake? I have. Now, early when we started reading this story, I pointed out our little friend the crow. Our book didn't actually go into detail about why the crow was there, but I have a great story. My older sister lived in San Francisco, and about 20 years ago, they had a very big earthquake. Well, before all of that happened, my sister had taken a break at her job and had gone outside to sit at a picnic table in a park and have her lunch. Well, when she was eating, all these birds came down, landed on her table, and basically were squawking at her. She thought this was very strange. Well, several hours later, there was a major earthquake in San Francisco. One thing that scientists are starting to figure out is animals actually can sense earthquakes are going to happen before scientists and humans can tell. So that may be one thing that scientists study in order to learn how to predict earthquakes. But I thought it was really interesting that they included the crow in this story, because they know ahead of us, or they sense that something bad is about to happen. And those birds actually flew down to the table to warn my sister. Unfortunately, my sister did not know what those birds were trying to tell her, but she was safe in the earthquake. I hope you enjoyed this story about earthquakes. And if this has piqued your interest, there's a lot of really great books and research out there that explain more about earthquakes, or do some video searching about an actual earthquake. Thank you for joining STEM Stories with Mr. Ewing.